All right, welcome everyone. We have a presentation by Evan
Machusak.
HEDIS on FHIR. I had the last name 5 minutes ago, but
Yeah, well, you're crispy this morning.
yes, I am.
All right, welcome everybody. Go ahead and get started here. My name is Evan Machusak. I am an Assistant Vice President of Digital Engineering at NCQA. I'm a software engineer by trade, and I run most of the FHIR stuff at NCQA from the tech perspective. So we do all of our digital measure work, including, what's that?
Oh, pull it up in the slide view.
Oh, but I'm going to be alt-tabbing a lot. Hold on. Is this all right? I'll put it up in slide view. It's all right. I think, if I can get it to work. How's that? Good? All right. So I do both the creation of the digital measures and also all of the tooling therein, some of which I'll be showing if time permits, just giving you a little preview of that. So for those of you, especially from Europe, who may not know what HEDIS is, it's our main product. It's what we're known for. Usually when we come to these conferences and we say, hi, I'm Evan from NCQA, they say, who? And I say, oh, it's the guys who do HEDIS. Oh, yeah, okay. And if I happen to be talking to a medical doctor, more often than not, they say, when's HEDIS going away? It's the worst thing ever. So HEDIS is controversial for some. But it is an evidence-based quality measure that assesses how well organizations deliver and manage care. It's measures, plural. It's a compendium. That is directly from the memo. So that is a direct quote. So HEDIS has been around since 1991. So back in those days, pretty much the only data you could get anywhere was claims data. And so therefore, HEDIS measures are primarily targeted to administrative data. So when you are going to compute HEDIS, you need to start with the payer data that you have. And then if you have supplemental data, which is our term for any data that did not come from your financial database, such as from an EHR, then you are also allowed to use that in certain contexts as well. So despite all of the advances this community has made in making data interoperable, unfortunately still today, payers are the best source of especially longitudinal records across an entire care continuum for a patient, because after all, the EHR records may be fragmented across multiple specialty EHRs and hospital systems, but your insurance company knows everything because they keep the receipts. So HEDIS is a national benchmark measure set that covers 227 million Americans that we know of. Could be more, probably is more. And some of the measures in HEDIS are CMS star measures, and that is important for incentive programs. For my European colleagues, stars is a big deal. A lot of money goes to stars incentive payments. So getting a good star rating as a plan is a very important thing. And therefore, HEDIS is, by extension, important. So this is sort of what a HEDIS measure kind of looks like a little bit. This is a screenshot of the first couple of paragraphs of the lead screening in children measure. This is part of HEDIS Volume 2. It is distributed historically, today included, as a technical specification written in English. It is distributed as a PDF. And so as a result of this, why are you shaking your head, Ann?
It's distributed as a Word doc.
Is it really? I thought we built it as a Word, so I actually have it open.
It's a Word doc. It's not even as...
It is a Word doc. So I've got it here. So it's a Word document, right? But I thought we actually published it as a PDF. Do we not? All right. All right. Well, anyway, we author it in Microsoft Word. So this is the source of truth. This is HEDIS. This is HEDIS Volume 2. It's Chart B, or Section B, Effectiveness of Care in Preventing and Screening. So this is how we actually do it. We split it up into Word documents by page number, as a matter of fact. So you can kind of see the sausage making a little bit there. This means that throughout the ages, you get this Word document, and as a consequence, you are required to translate it to something that can actually be executed. Many companies do this every year. We call them vendors at NCQA. I have two of them right over there, my Cotivity buddies right there. They are a vendor who does this. And so it's a lot of burden to do this. They have to compute all of the HEDIS scores by translating it from this PDF Word document into some type of logic. So we know that there are people who implement HEDIS as C++ libraries. We have people who are doing it in SQL like Cotiviti does. And pretty much any tech stack you can imagine, someone has built HEDIS on it. They're almost all proprietary solutions. I believe all of them are. And so this is kind of burdensome. So over the last couple of years, NCQA has begun to incorporate and implement its digital strategy, which essentially means moving from the dark ages of Word and PDF into leveraging the work that this community has been doing over the last 10 years. So the major theme, the North Star that we kind of use to justify why we're doing this is burden reduction. That encompasses a whole lot of aspects of a quality management program, some of which is policy, some of which is technical. I represent the technical side, and that's what we're talking about here at DevDays. So from that perspective, in order for us to reduce burden for operationalizing HEDIS every year, we sought out to create computable DQMs for the HEDIS measure set. So effectively what that means is building the HEDIS measures as CQL measures that can be run by CQL engines. So currently, the CQL community, if you have your ears to the rails on that, I don't want to say it's fractured, but there are multiple implementations, none of which implement the full spec completely. We have specification tests, somewhere around 1,500 of them, and no single CQL execution engine implements all of them, meaning they pass those tests. I didn't draw it here because I kind of, to be honest, I made these slides like 2 days ago, but it's a Venn diagram, right? Each measure or each engine implements most. There's a huge amount of overlap, but then there's these little slivers on the side of tests they don't pass. So that's a bit of a problem when we produce CQL measures because it's anyone's guess whether the CQL we wrote will work on the JavaScript engine, the Java engine, the .NET engine, who knows, right? So we need to solve that problem, and so we convened the digital quality implementers community through Levitt Partners. Mark, who's in our audience here, is managing that project for us. He's kind of leading that community at Levitt. So anybody who's doing CQL tooling, if you've missed the DQuick conversations that we've had here at DevDays and you're doing anything with CQL where you're making an engine or you're leveraging someone else's engine and you're not part of DQuick, talk to Mark. It's important to get involved so that you can empower the people who are going to be using your technology to run HEDIS. And so, of course, a big part of that is also proselytizing digital technology in general. There's a lot of skepticism about digital measures in the industry. I would say in our little hype chart, we're probably in the trough of disillusionment on CQL digital measures at the moment. I hope that this time next year we'll be well along the slope of enlightenment, but it takes a lot of effort to get there. So, so let's see. We started exploring CQL for HEDIS probably, when was it, 2020, Ann? 2021? 2019. Okay, so a long time ago. And at that time, CQL was even less evolved. This is 5 years ago. CQL is one of the more rapidly evolving technology environments in HL7, maybe. I could be wrong, but it was much more primitive back in 2019. There were fewer options. So we started exploring what it would take, and by the time 2023 rolled around, we were fairly confident that digital was not only ready for prime time, there was enough FHIR critical mass to make it worth doing, and the tooling had evolved to the point where it made sense for us. So in early 2023, we started in earnest, and we digitized all of something like 82 of the volume 2 measures into CQL. There are a few more than 82 total HEDIS measures, but some of them are things like survey measures. They, CAPS and what are the other ones, Ann? It's CAPS and
Medicare caps, commercial caps, and then the children with chronic conditions.
Okay, so children with chronic conditions and then a couple of CAPS varieties. And those survey measures are generally conducted completely outside of like data. People don't use their admin databases or EHRs for them. They pay people to call people on phones. If you've ever gotten a phone call after you've been at a hospital where they ask you about your stay, they're conducting a CAP survey on behalf of probably your insurance company. So we did most of them. all the ones that can be computed from admin and EHR data. We have the entire 2023 set done. For those of you who know HEDIS, we are currently wrapping up the reporting season for 2023 data. So we're currently building the 2024 measures, which will be reported next May. We have all of the reporting versions of those measures done at this point, and we are currently working on some of the allowable adjustment configurations, which are also part of our DQMs. And we are also producing some supporting evidence. And what that means is that when you compute a numerator for a measure, great, you're in the numerator. But if you're not, and you've got someone who's trying to do a care gap closure on you, usually it's a nurse who's going to be reviewing your records. It's important to understand who you're trying to care gap close. So for example, if you know that somebody is non-compliant for the breast cancer screening measure, they're going to be a numerator miss, and they're just a little bit too late on their last mammography. They have to have one within 27 months. Let's say they had it 30 months ago, and so they just need to get in the office and get on board, right? You're going to approach a patient like that far differently than a 75-year-old woman who has, maybe 74, because I think that's the age range, 74-year-old woman who has never had a mammography in her entire life. If she's never had one and she's 74, you might not bother trying to get her into the office because she probably had a reason for never going. So, you know, that information is useful for care gap closure. So we try to omit some of that. CQL in general has this bit of a dichotomy problem where if you code the measures in such a way to execute as fast as possible, it means that you're not going to produce a lot of intermediate information that would be useful for care gap closure. So there's this spectrum of fast, readable, and debuggable. It's competing interests sometimes. So it's hard to figure out where to put the needle on the CQL that you write, but we tend to lean towards fast execution because we are a quality measurement program that's a national benchmark that's run on millions of patients. So for us, it's a lot of volume. So how do we do it? What are the tools that we use? So we have explored almost every variety of CQL tooling that has existed since the dawn of time, also known as 2019. So we started off trying to align with the CMS tooling. So at that time it was MAT, I believe, right? Now it's MAT-E, but MAT and Bonnie, we were using those for a while. The problem with those tools in particular is that if you upload anything to these tools, they become public. Everyone can see them, and HEDIS is intellectual property. We charge for it. You have to have a license to use it, so obviously we can't upload it to those tools. So we tried cobbling together the same core tooling that those systems use, but privately. So we had a Visual Studio Code extension back in the dark era. It was not the one that you all use today for CQL. It was one that we spun in-house by our good friend Brian, who has since moved on to MITRE, works closely with Sam. So Brian put that stuff together for us, and it used the JavaScript engine and Visual Studio Code. That became problematic for us because those tools were not designed to run millions of patients at a time. And even doing the testing at the scale that we were doing, which involves some synthetic patient tests that have 80 to 90,000 patients, we would find situations where we would try to run them, and 13 hours later, we had gotten through 300 patients. So that was a non-starter. So eventually, we congealed upon creating our own tooling with the express purpose of authoring in mind. So we created what became the FHIR CQL SDK. So if you've seen that, used that, if you attended Rich's sessions, he was demoing the same basic technology that we use to develop measures. And the idea behind it was to convert CQL to a language that is more easily debuggable, so that software engineers who are writing CQL can step through their code. And I will show you the code a little bit. I'm not going to do a whole debugging thing because Rich already did that. So if you missed his presentation and you want to know more about that, just watch his and he'll do the whole tutorial. So we use Visual Studio 2022, the full-blown IDE, not code. And we organize our projects, which I will show you momentarily, into projects where we include the CQL files. We use MS Build scripts to compile them into C# code into another project. So we create generated C# files, and then we compile those. And once those are compiled, we now have them as DLLs. So anyone who knows .NET means anything you can do with the DLL, you can do all kinds of cool stuff now with CQL. So you can create CLI tools, you can create, you can distribute them as NuGet packages if you want, you can make them Azure functions, so it's pretty cool. And the other thing that we do with those compiled C# files is that we write unit tests using C# unit test frameworks directly against the converted CQL. So that's really, really useful for us because as we're writing our tests, we can debug them, step through them. And because we are using a C# SDK, we can debug straight down to the level where the operator is executing. So as we were developing the SDK, naturally we had bugs, like the add operator for CQL is not working correctly, let's say. Well, you can debug all the way down to that and see that, you know, we have a bug where if it's null on this side and not null on that side, we're not returning null like we should be. We could figure that out. So we have quite a few tests against our converted CQL libraries. And it's really an efficiency issue because it's the native same kind of tooling that every developer uses in their day-to-day job, so it makes CQL feel less foreign. Trying to create tests in any other kind of framework, like we've experimented with using fish, which we still use for our CMS contract work, but creating a fish file and having it convert to JSON and then try to run that JSON file, it just adds a lot of cruft to the whole process as opposed to just being able to write assertions based on simple, I want to call this helper function and I want it to return this. It's a little easier. So I'll show you what some of those tests look like. However, we still need to use the Visual Studio Code extension because it is the only show in town that gives you syntax highlighting for CQL currently. I believe somebody did one for IntelliJ as well, but we're not an IntelliJ shop, so we're not going to use that. So we still use Visual Studio Code just so that when we're writing the code initially, it's prettier. So at this point, I'll talk this slide, but then I'll show you the actual files because I think it'll be a better presentation. The way we organize our thinking around how we go about creating a measure set is first we start with what we call our base level libraries. And so these are essentially corollaries to the FHIR helpers library that you have all seen if you've used CQL. FHIR helpers is great, but it's not completely complete for all the things we need. So we try to segment our libraries into things that are general purpose CQL helpers. These are things that have nothing to do with FHIR and they have nothing to do with our domain, which is HEDIS. They're simply things like creating error helpers so that we can quickly emit an error, right? It's just an overload of the message function, but you don't want to write message and then try to remember what the parameters are supposed to be. You just want to say error and pass in a string. So it's things like that. And then we have a whole bunch of stuff with intervals because interval math is like a whole. Quality measures are essentially just intervals and value sets. Those two things, pretty much the only aspect to it. And then we have similar libraries, but they're dedicated to FHIR at large, and those include helper functions like dereferencing. So I've got a reference in a resource, I have to go get the actual target resource and then do something with it. So, and then we have HEDIS libraries that are common to all of our HEDIS measures. So HEDIS has an entire volume. I was showing you this Word document. This is page 69 to 126. The first 70 pages are what we call general guidelines that are things like you may exclude patients who are dead, and if the claim is a lab claim, then you can't use it because we don't trust the lab claims. They're false positives all the time, and it's stuff like that. Continuous enrollment, for anybody who knows anything about HEDIS, continuous enrollment is essentially a nightmare, and so we have all of that in our HEDIS libraries. And then we break it down into resource-specific libraries, helpers for things like conditions, procedures, and so on. And these are mostly things like normalizing onsets. Condition onset can be 5 different things. It can be a range, a ratio, and all this other jazz. So we want to just normalize those into our dates, single dates, so that we can work with those. And then we'll break it down even further into topical libraries. So we have a whole kidney disease library, a whole cardiovascular library, a whole cancer library, because several of our measures cross into those lines. And then finally, we will break it down into measure libraries. We have a couple of measures that are in the same general ballpark, like childhood immunization status and adult immunization status. They share a lot of the same logic. So we put those into an immunization measure library, and then finally we have our measures. Generally, as we write our CQL, we have a couple of kind of key principles with the way we write them. We don't like definitions in CQL very much. They're used heavily in ECQMs, but we use entirely functions. So generally speaking, we like to write fluent functions that do all the work. And we put them in libraries. We only use parameters, CQL parameters, that's input into the measure execution, like the measurement period. We only put those in the entry point libraries. In some measure sets, you see people putting parameters in all of the child libraries as well, so that they're like globally available. We don't like that pattern. We've had too many issues with conflicts. A simple example would be we transitioned from making our measurement period date times to dates because we don't care about the time. We're talking about days, not like minutes for the measurement period. And trying to make sure that we converted all of them simultaneously was kind of irritating. We ran into lots of problems with that. So we decided, no, parameters just in one place, and if you need them in a library, you pass them as parameters to the functions in that library. We don't use contexts, like context patient, anywhere except the actual library itself, or the measure itself. No libraries use contexts. We operate almost entirely on lists, so we prefer our functions to both receive a list of something and return a list of something. Our mental visualization for how we think about HEDIS is it's a series of filters. You start with the patient universe, and then you subsequently narrow down that universe until it's very small. And at the end, you have either an empty list or a non-empty list. If we're talking about a numerator, for example, if the list is empty, you're not in the numerator. If the list has something in it, you're in it. So therefore, creating functions that are all operating on lists makes that pattern a little bit more cohesive. We try to take FHIR data and convert it to system types early. So for example, we try to normalize FHIR periods into system intervals as fast as possible. We don't like to deal with FHIR types in our libraries because we want these to be non-FHIR specific as much as possible. We prefer to avoid tuples and choice types. Those are two features in the CQL language that we do not like to lean on too heavily because it creates a lot of problems in our own tooling, and it's really hard to debug. CQL does not have named tuples, so you cannot create, like if you wanted to have like a point that had two integers, x and y, you can't call it a point. It's just tuple x and y. So you have to redefine it everywhere you use it, so it makes it very cumbersome as an API. So we do all that cool stuff. We write all the CQL according to our style guides, which if I have time, I'll show you a little bit of that. When we test HEDIS, we have over 2,000 manually authored unit tests. These are usually for things like our core libraries. So we have about 50 or 60 tests that test continuous enrollment alone. And they test all of our common libraries. But the main way we test our HEDIS measures is that we've had a certification program that Anne built for us back in 1998, was it? 2000. So for 24 years, we've had this program. And we have been creating synthetic data long before Cynthia was cool. It creates, for each test deck, we create between 20 and 120,000 synthetic patients for each measure with a score key, which tells us if those patients belong in the numerator or not. So we test our CQL measures against these certification decks. We run them all night, or every night, in a CI/CD tool chain. We use Azure DevOps for this. So we have probably around 4 million total patients executed. The average is around 50,000 per measure. Some decks are bigger, some decks are smaller. It depends on the measure. Some are more complicated. So we have a pretty low-powered build agent, and this takes about 6 hours to run total. Some measures take 1 minute, some measures take 1 hour. Depends on the measure. Let's see. This is something I get asked a lot, what the effort breakdown is. We probably spend 20% writing CQL and 80% testing it. And that's the first time we write a brand new measure. The yearly update process, when we already had a working version of 2023 and started on 2024, it was only about 5% writing, and the 95% of the time was testing. The first conversion of HEDIS, writing all 82 measures, took a team of 8 developers, ranging from juniors all the way up to principal level developers. It took us about 8 months to do. The yearly update has taken about 2 months to do. And that's working part-time. That's 80% time. Lessons that we learned about this process is that a lot of the measure patterns are truly senior developer level work. They are not something that someone who is learning programming for the first time is going to be able to figure out. The classic example I like to use is the pattern that we have related to DTaP vaccinations. You must have a vaccine dose every 14 days, which sounds easy to say, but when you're actually trying to deal with immunization resources and it requires an aggregate query pattern, which is complicated to come away with. The biggest challenge overall is deduplicating events. For measures like AAB that are event-driven, where the same person can be in the numerator multiple times, it's critical to make sure that in a real scenario, you're going to have a medication dispense, then you're going to have a claim for that medication, and then you're going to have an explanation of benefits for that claim event. You can't count all three of those. That would be 3 events. It's only one event because it happened on the same day. It's actually the same event, but when you're correlating a clinical resource you got from the EHR to a claim and an EHR or an EOB, there's not some universal ID that links them all together. You just have to go by date. So that is really complicated, particularly because CQL does not have a group by operator. So imagine trying to figure out how to write SQL, do something like this if you're familiar with that, and you can't do a group by. It's hard to figure out how to do it. We have other measures that require information that isn't generally found in the record. Most EMRs are not going to include medication resources along with the patient record. There'll be some kind of canonical static resource. But then we have measures like AMR, our asthma medication ratio measure, that requires dose information by unit. And that information is not going to be in the patient record, but it's also not a value set. So how do you import it into the CQL? It's tricky stuff. And I won't even touch upon risk-adjusted measures except to say that PCR is a nightmare. And so it's very difficult to actually pull off some of these measures. Fast debugging makes all of the difference. If you spend a lot of time poking at theories and having to write CQL fragments to test why a patient's not working, the iteration process is just too slow. So once we began using visual debugging that Rich covered very well in his session, we were able to dramatically improve the time it took us to develop HEDIS measures. And the last point is that informaticists are force multipliers. If you have your informaticists writing the code, that's generally not the best way to use them. The best way to use them is to take this, is to help you go from this to breaking it down logically. So for example, Anne and her team helped us figure out the correct way to break down our topical areas. So she sketched out what functions we would need for kidney disease, what functions we would need for cardiovascular, because they're common across these measures. So they take the language and break them down into essentially like almost function signatures. Like you need something that computes this, you need something that computes that. And so we started by writing libraries before we even touched the measures based on the work of informaticists. So having them write code sometimes is not ideal, especially for some of the harder stuff, because they're going to beat their heads trying to learn how to do really advanced level querying stuff when you can just pull a developer off a project and say, can you figure this complex query out? It's just faster. And I have, how much time, Dave? What time is it? It's 10. I've got 15 minutes. I'm going to just spend 5 minutes showing you a couple of just screenshots of the stuff here that I've got hooked up so I can show you the tooling just a little bit, and then we'll go to questions. So, so we've got our lead screening measure. I showed you that a little bit. I can't show more because the lawyers will kill me. So then we have our CQL, and I'll just show you kind of how that looks in real life. This is Visual Studio Code I have open. Ignore the red squigglies for now. I don't know why they're showing up, but don't worry about it. I just cloned this repo on a fresh machine just now today. So, all right, so we follow the general like Visual Studio Code paradigm of having an input folder. And then the one thing that our tooling can do that the standard VS Code extension currently can't, although I know Rob will fix it, is foldering. Foldering is really important when you have a whole lot of files. So we have a libs folder. So I mentioned some of these CQL common concepts. This is like a CQL base one that is got our error stuff in it, you know, it's useful little things, not too much in there. We have a FHIR common, which is essentially just FHIR helpers plus, more or less, and this is our dereferencing functions, and we have some date intervals and some other stuff in here. This needs work because it doesn't take into account leap seconds. We have a whole library dedicated to intervals. And so then, you know, you go down into our topical libraries, and we have all these clinical areas here. These are all the broad strokes areas that HEDIS measures cover. And then we have our measures themselves, which are going to be in a different folder entirely down here in measures. And so we have one folder per measure. I have APM expanded here. I don't even know what APM is. Which may.
Pharmaceutical, metabolic, it's looking at metabolic tests for some.
Metabolic tests for something. So
For some
we use the CPG kind of basic pattern where we have our concepts, which are the value sets that we declare and any kind of direct reference codes. And then we have the elements, which are like the measure library that include the actual like bulk of the logic. So we've got all these little libraries like is continuously enrolled with medical benefit, right? So this is basically just calling a helper function, but it is the necessity for APM. And then we have the reporting measure, which is actually where all the defines are. So this defines the initial population, and this has the input parameters in it. And look, I'm violating my own rule. We have a tuple. We use this for our internal tooling. Yeah. Well, it's actually, I'll blame you, Rob, actually, because we can't put these on the library declaration. We would have just put the metadata tags up here, but the CQL won't compile if we do that. So we have to create a tuple down here that we can use so we can get this metadata about the measure. We use this in downstream tooling to help us identify this measure in a UI. And so these groups, these little annotations are also just helping out with creating the measure resource. So these are where all the core defines are, and that's how we organize this. And then the bulk of the work gets done here. So this is our solution. We have the FHIR CQL SDK projects included directly. This is so that we can debug into them if we need to. So like the SDK has operators. This is like where all of the fun stuff is. This is where we have like the difference between operator and CQL defined, right? So if you think the difference between operator and CQL is not working, you can just slam a breakpoint on here and then debug it as you are running a patient. So we have the FHIR CQL SDK pulled in. We have tests. So our main test, I believe, is this. So we've got like, let's see, do we have a continuous enrollment one? Is that in coverages, Damien?
Should be, yeah.
Yeah, so we've got unit tests for our coverage library. And so what we're actually doing here, you can see in the C#, what we do is we instantiate a coverages class, which has been converted from the CQL. And then we can actually start calling direct functions. So if I went to look into the coverages library in my CQL that I had open, you'd be able to see that there's a function called date intervals. And in fact, if you navigate into this, you can see we have the attribute here that tells us what actual CQL defined name is associated with this function. So you can debug this if you want, but then we just create the test state or the test data right in line. We create the coverages just by instantiating very minimal FHIR resources here, and then we define what the expectation is, what the actual is, and then we assert that they're equal. And we have thousands of these. And then show you how the actual generated code looks like a little bit. It's kind of ugly because this is all generated by a tool. So you're going to see a lot of double underscores and a lot of really bad naming, things like that. So we will actually break up a simple CQL declaration into its little constituent parts here into aptly named variables A, B, C, and D, because of course, right? But the key is it's not about what's on the left-hand side, it's what's on the right-hand side. So you can just put a breakpoint here and debug and figure out what's going on. So this is all generated for the purpose of authoring. Once you've authored, you don't really need any of this stuff. So we can just build these projects directly from Visual Studio, and then we can use our Test Explorer to run our tests. We have a whole project called Deck Test, and this is going to run the individual measures against specific certification test decks. And then we have nightly builds. This is, let me show that real quick. So we have pipelines, and you're going to have to forgive me here because you're going to see a lot of failures because we are in the process of doing a measurement year. So there's a lot of failing runs. So like this one, for example, this DEX one that failed last night. Let's see, this one took 5 hours. And let's see, you can see that we have individual tests for each of these measures. So this runs nightly. So AAB is failing, AMR is failing, some of the harder ones. And you can see there's wildly different times. So like ADDE is apparently complicated and takes almost 80 minutes.
How many tests they have?
Yeah, the decks are different sizes too. So like DMSE, I think, is one of the faster ones. That one's like lightning.
CCSE has like 17 different.
Yeah, all right, so DMH took 31 seconds, and DMSE took 2 minutes and 8 seconds. And keep in mind, this is running on a build agent. So this is like, I don't know, some hardware. It's like a laptop Anders plugged into the... Yeah.
DSME is just looking for a depression screening. Did you have a depression screening done? ADD is antidepressant medication. First of all, you have to find that if you're on medication, then second of all, you have to find if you had the correct follow-up visits in the correct time. So that gives you kind of a sense of the difference in timing and the difference in complexity
Let's see
of
how
the
long
measures.
PCR took. PCR took 52 minutes. Not the slowest, surprisingly. PCR is a bear. It's one of the risk-adjusted measures. That's very important. So that's plan all-cause readmission. So Medicare cares about that one deeply. So with that, I really want to give some time for questions that Ann can answer. So direct all questions to Ann, but floor is open.
Kind of a trivial question, not really super important, but I'm just curious. How do the tests that were created in Ann's framework make it into the C# unit tests? Is that a manual process or?
That's a good question. So the current certification process that Ann invented, again, in the year 2000, let's not forget. Let's try to remember what we were all doing in Y2K. They are fixed with test files that vaguely resemble CPCDS. They are designed to be a pseudo-administrative database. It's sort of the idea that if you took an admin database and dumped it into a flat text file, what might it look like? So the first thing that we had to do to operationalize this was to convert those decks into FHIR, which Ann essentially told us how to do. Again, informaticists being force multipliers. And I can actually tell you an anecdote. I was talking to a company who actually had some Ukrainian developers who were busy trying to do HEDIS while there's like bombs dropping. It was very, very noble of him to be working on HEDIS at a time like that. But he spent like 6 or 7 months trying to do the same thing, turn certification decks into FHIR. He didn't even know that we offered guidance in that direction. So I got on a call with him and he's like, can you help me? Yes, of course. Here's an example, right? So we had to figure out how that mapping worked. I will say that our certification programs are transitioning to native FHIR, so we are now building test decks in FHIR by default. But because this is healthcare, we need a 3-year runway. So the FHIR versions of all of our certification decks are available for anybody who wants to use them. So we had to convert them. And so Damien wrote this tool right there. So any other questions?
I have some comment. Like my background is like .NET C#, and I am new to CQL. So like a couple of slides you talk about like the best practice of CQL and best practice of C#. So there will be some conflicting things will happen. Whatever you write in best practice on CQL, that may not play with the C# converted version of C# actually. Another comment, like how you like generally maintain the source code actually, like it is a SQL put into a repository or the converted C#.
So in this solution, which is our 2023 HEDIS, you can see we have this project called Measures with all this generated C# stuff. Ewout's new guy, Paul, will yell at me because these don't have a .g after them for generated C# files, which by default in a .NET environment will be excluded from source control because they're .g.cs, they're generated. So they are generated by a tool. And I think I was smart enough to at least do this. At the top of every file, yes, there is a generated code attribute that describes how this is made. So what this means functionally is we don't check these files in. We instead generate them on each build. So they're all generated, and they're all basically, I'm not going to say that they're trash, but they're generated code. They're about as good as, like, I don't know, an Antler generated parser or something like that. It functionally works, but it's not the kind of code you'd expect to write for real. And in fact, if you really start digging into this, because it's generated, CQL is a functional programming language, so to turn it into procedural statements like this that can actually be put, the goal was, I want breakpoints on these things, so I'm going to try to see a function that's actually decent. These are all stratification nonsense things. I should probably just look at a library. Like advanced illness is probably all right. Advanced illness is good. So, I mean, you can see, like, this is dates for outpatient visits with advanced illness, and the first thing you see is this bizarre, you know, kind of private function named A that, you know, and we have a function called OR, and, you know, it's hard to read. So this is, you know, if I had checked this in and pitched this as, yeah, these are the measures, you know, when you saw someone write code like this, you'd throw up in your mouth a little bit because it's terrible. So
Yeah.
we focus entirely on best practices in CQL, and then we let this code converter do the rest, and we only use this for debugging. And in fact, we have a build tool, I think it's part of the SDK, that actually skips this step, so you don't actually have to emit the C# if you want. You can just skip it entirely, and it will just spit out a DLL for you. So you can go straight from CQL to DLL, and then you don't have to look at the code at all. So
Just in general, that's a standard practice or best practice in software development industry, right?
right. So there is actually a cool thing that Avout tipped me off to, which is if you really wanted to, you can pipe this code through like Copilot, and you can say, Copilot, can you rename these variables to not be terrible? And it will. It'll do a pretty good job. And then you can also ask, Copilot, can you like clean this code up so it's not nearly as ugly and to make it look more like a human would write it? And it does a pretty good job. The reason I haven't integrated it into the SDK and made this like look good so it looks like a human wrote it is because it's AI, and it hallucinates, and it's right 80% of the time. But then there's that other % of the time where it generates code that doesn't exist, it doesn't compile, it doesn't work, and it's wrong. So until it works 100% of the time, I don't want to put it in the SDK tooling. So
We can use it for the names probably, though. That's still on my list. Whenever I see this, I'm like, oh, we did this experiment.
I know.
right?
You're frothing at the mouth to do it.
But it's
I know.
magic that it is like the ChatGPT or what we pasted it in is actually able to derive a good name for these variables, which are pretty much unreadable to us.
I'm going to try to find a small function here. All these are huge.
So that's still something, it's the kind of things in my head. I'm like, oh yeah, when I go home, I really will do that. But in the end, well, who
This is a
knows?
decent one. This is small.
But I mean, given these are basically debug, it doesn't
Right.
matter too much that you understand, right? Those, yeah. So I mean, this is a common practice, I would say, in software development. So.
Yeah, but we wanted to do something with AI too, right? So this was the thing. Yeah.
One thing to mention too, just to pitch the DQIC again, you mentioned about the CQL. Part of what we're doing in DQIC is changing the CQL. So there's a recognition by the owners of CQL that it needs to be updated based on the work that's been done here. And the idea is this is an implementation which is going to continue to get better, but we have Google, Microsoft, Smile, FHIR, and a number of others that are joining in this community. And the HEDIS group is donating a lot of their code to the open source community and showing, at least on the screen, some of the details you're seeing here to spark your thoughts around, oh, this is how I would do it in Java, or this is how I would do it in JavaScript. So if you don't, the idea is this is still awesome, but the DQIC is, the NCQA doesn't want to be in the software business for a long period of time. They want the community, you all, to be these people so that they can do more clinical informaticism.
Yep. All true, all fair points. Any other questions? Yeah, so we're on the journey. We are doing it for real. So HEDIS is like ready to go. So all we need to do is get it in the hands of everybody who runs CQL and working with a couple of people whose names I won't mention, Rob. And anybody else who wants to, rock and roll with HEDIS CQL. TQuick is the place to start. You can also contact us and we'll see how we can hook you up. I wish I could make HEDIS open source, but we have to make money to be able to actually pay the people who do this. So it is IP and we do sell HEDIS. So it is a licensed product.
Rich is giving a Let's Build session this afternoon too.
I thought it was. It's after. Oh, great. Okay, perfect. I thought it was already happened. So anybody who wants to know more about this and actually do a Let's Build, you can actually basically recreate what we are doing here. He's going to go through this process, but he's going to use an ECQM that is free and open.
And
so it will be great. So
It is 1:30.
1:30. So go to Rich's presentation and do the Let's Build, and you will come away knowing how to essentially do what we are doing. And also, if you are intending on integrating measures into your .NET project, Rich's talk will help kickstart that effort for you. So, anybody else? Thank you.